Hello students, I welcome you to this session of Python programming. In today's session, we'll be discussing about the fraction type in Python. Now, fraction is the functional cousin to the decimal fixed precision type that we learned in the previous video. And the idea behind using fraction type is the same, that is to address the floating point types numerical inaccuracies. So whenever we are using floating point type to represent floating numbers, then there is some problem with its representation. So like decimal, fraction also resides in a module with the module name is fractions and the function name is fraction. So this function fraction requires two arguments for you to pass. The first argument is the numerator and the second argument is the denominator. So for example, if you need to represent a number as a fraction, what you can do is you can first import the fraction function from the fractions module. Then you can call this function and pass say two arguments, say 1 and 3. So 1 is taken up as the numerator and 3 is taken up as the denominator. Okay. Similarly, to represent another fraction, we've taken y is equal to fraction 4 comma 6. So if you represent it here, if you try to see here, x is this and y is this. So automatically it is simplified to 2 by 3 by the concept of the greatest common divisor. Okay. Now, once created, you can carry out the various mathematical functions. The addition operation, the subtraction, multiplication operation. You can all carry it with the fraction function. And another way of representing fraction object would be through passing it instead of two integers, simply pass it a floating point number as a string. Like we have done here, this fraction function is passed float number but enclosed in single quote, so represent it as a floating point number as a string. So this 0.25 is taken up as a fraction 1 by 4 and this 1.25 is taken up as a fraction 5 by 4. And obviously if you add them, you get the answer as fraction 3 by 2. So let us go to the Python interpreter to see actually how we can work about with the fractions. So I can just start here from fractions, import fraction. Okay. Once ready, then you can use this fraction function and say you can pass it two arguments, and similarly you can use this fraction function and you can pass it the two arguments, say 4 and 6. So if you print x and you print y, you see the values that it represents, and just see that fraction 4 by 6 is automatically reduced to fraction 2 by 3. And if you print their values, obviously they'll be printed in the fraction form. And then it's easier for you to carry out certain operations on them. So if z is x plus y and if you print z, obviously answer is 1. 1 by 3 plus 2 by 3, the answer is 1. If you multiply these two, okay, and then if you print it, it's 2 by 9. Similarly, I told you in the presentation that another way of creating a fraction would be to pass it a floating point enclosed in string form, right? So what you can do out here is you can represent this. So if you print this, this is 1 by 4, and if you just make it this and you see it, it is 5 by 4. Okay, this is another way of creating fractions. Now the idea behind using these fractions obviously is to have greater numeric accuracy in fractions and decimals. That is having greater accuracy in representing floating point numbers, and the float type obviously is unable to represent them in the best possible way. And with this fraction and decimal types, you can get exact results, although at the cost of some speed and code verbosity. That means the speed would be reduced and you would have to write more amount of code as compared to when you write float. For example, if you want to calculate this, then you just write here 0.1 plus 0.1 plus 0.1 minus 0.3. But this should give us a 0 answer, but it gives a very small value, not exactly 0, but something like 5.55 into 10 raised to a minus 17. This is because of the limitation of the float type to represent these numbers in the memory. Now, if we use this fractions type or the decimal type, then we get the answer as 0 for this type of calculation. Okay. So we saw in our previous video about this decimal type. Now let's run this. I'll just copy this the fraction type for you. from here so that we can see that it gives us the accurate result. So let me store it in the variable r. Okay. And then if I print r, you will see the result is 0. Okay. Similarly, if I run this, we have seen it in the previous video, the answer would again be 0. So we can get this accuracy, but at the cost of some reduced speed and more code. But then you can see that this both these types, fraction and decimal, can do some work that the floating point type does not do very well. In my next video, I'll be discussing with you this dynamic typing model in Python. A very important concept and very important for you to understand it, because it could be there for everything that you study from this point onwards. So till then, goodbye, keep watching.